Now, what this is called when you write two equations and they're both lines like we saw in the last example is called a system of equations. And because they're both lines, we call it a linear system of equations. So in this example, there's going to be enough information that you should be able to make two equations, and they'll both be lines. So write this down, see if you can come up with both equations. So a word problem like this, a good strategy, draw a diagram. Are you okay with calling length L?
Sure.
And width W? Now, if the first sentence here, a rectangular stage has a perimeter of 158, how do we write an algebraic equation that says that?
2W plus L. 2L equals.
Perfect. 2 W's plus 2 L's is 158. Again, you could rearrange this. You could make one of them x, one of them y, until y equals mx plus b form, and you could graph that line. The width of the stage is 31 feet less than its length. How do we write an algebraic equation for that?
LW plus, 2W plus 2L.
That's this one. But for this one, the width is 31 less than the length.
2W equals 2L take away 62.
You could double it, but why not just keep it with 1W? The width is equal to
L minus 31.
L minus 31. And if I was changing this to y equals mx plus b, I might make the w y, because this is already y equals x minus 31. So that one might be kind of nice to do that. And then you could rearrange the first one.
How are we supposed to solve this? We only have one number.
We have two equations. And what we're going to learn in this unit is any time that you make two lines and you graph them, as long as they're not the same line or not parallel, they're going to cross. And where they cross, you'll find the solution. Now, students said that the answer to this was 55 feet by 24. Verify that the student was correct. So we're going to look at what this word verify means. I'm going to call this equation 1 and this one equation 2. And we're going to verify both of them. What verify means is you don't know if it's true or not, but you'll always have a left side of your equation and a right side of your equation. So if we look at equation number 1, the left side of that equation says 2w plus 2l. We're going to draw a line, and the right side of our equation is 158. What we want to find out, are they the same when I plug the numbers in? We don't use an equal sign because we don't know they're equal yet. When I plug in a number, I want to plug in the width would be 24 because the length is longer and the length is 55. And if I do this, this will be 48 plus 110. Does it equal 158? Yes, it does. So we have verified that equation 1 is right. But even with our chicken and horses, while we were guessing and checking, we often had it add up to 50, but the legs weren't right. So now we have to check, does it also work for equation 2? Our left side and our right side. In equation 2, the left side was just w. Right side was the length minus 31. So let's plug in our numbers. Our width was 24. And this is 55 minus 31, which is 24. Yes. So that is the correct answer. They were able to figure it out, and you can check it by plugging the numbers back in. Is that enough, or do you need part of the